Welcome dear students. We can start our JEE Main January first section 20 seconds evening session question paper. So, let alpha, beta, gamma, delta be the coefficients of x raised to 7, x raised to 5, x raised to 3 and x respectively in the expansion of x plus root of s cube minus 1 raised to 5 plus x minus root of s cube minus 1 raised to 5, x more than 1. U and V are satisfying the equation this alpha u plus beta v 18, gamma u plus delta v equal 20. Then what about u plus v? So here we can observe that y is equal to root of x cube minus 1. So what is y square? Is x cube minus 1. What about y raised to 4? X raised to 6 minus 2 x cube plus 1. Now the expression is x plus y the whole is to 5 plus x minus y the whole is to 5. You know this is x raised to 5 plus 5x raised to 4 plus 10 x cube y plus 10 x square y cube plus 5 x y raised to 4 plus y raised to 5. Then the second one, this is x plus y the whole is to 5. X minus y the whole is to 5 is equal to x raised to 5 plus, minus 5x raised to 4y plus 10 x cube y square minus 10 x square y cube plus 5 x raised to 4 y raised to 4 minus y raised to 5. You want to add the sum. So, take the sum. We can see this is x plus y the whole is to 5 plus x minus y the whole is to 5. This will be 2x raised to 5 the first term, and this cancel, you got a 20 x cube y square plus this to be 10 x y raised to 4. So already you know what is y square. So 2x cube plus 20, this is x is 5 cube into x cube minus 1 plus 10x into x raised to 6 minus 2x cube plus 1 is y raised to 4, and that is actually y square. Now expanding this, it is equal to 2x raised to 5 plus 20x raised to 6 minus 20x cube plus 10x raised to 7 minus 20x raised to 4 plus 10x. So alpha, coefficient of x raised to 7 is 10, beta, coefficient of x raised to 5, that is 2, gamma, coefficient of x raised to 4, that is minus 20, and gamma s cube is minus 20, good, and delta is equal to x, that is equal to 10. So we can see these are the values inside. Now we can frame our new equations. Using that, we can see alpha 10 u plus beta 2 b is equal to 18, gamma that is minus 20 u plus 10 b is equal to 20. So best we can multiply by 2, that is 20 u plus 4b is equal to 36. So adding, you got at 14b is equal to 56, then b is equal to 4. Replacing 4 here, then 10 u plus 8 is equal to 18, then u is equal to 1. So u is equal to 1 and v is equal to 4. Your requirement is what is u plus v. U plus v is equal to 5. So option 1 is there. In a group of 3 girls and 4 boys, there are 2 boys B1 and B2 and the remaining girls. The number of ways in which these girls and boys can stand in a queue such that all the girls stand together and all the boys stand together, but B1 and B2 are not adjacent to each other. So we can make the condition as G1, G2, B1, B2, B3 and B4. There are 3 girls, okay. G1, G2 and G3, this. it may like the Q. Otherwise, we can see basically B1, B2, B3, B4, G1, G2, G3. These are the two types. These two are, first of all, we can make a girls first then boys, or boys first then girls. These are two aspects. But you can see the condition is given there. There are two particular boys. They will not, all boys stand together, but B1 and B2 are not adjacent. They are ready, but they will not adjacent. So we can see here there are two aspects. Don't mind the two aspects, we can wait there. Without that either two condition, we can see what may be the condition inside them, and after we can club together two B1 and B2 together and remove the total, will give the answer of it. So before identifying that two group, we can see this one. Without any change, we can see this is equal to 3 factorial and it is 4 factorial. This is the condition. Among them, if they are in a single block, they are together, that we can subtract. So if there is a single block, then block itself can be permitted 2 factorial, and this 3 will be what? 3 factorial, and this is 3 factorial. This is they are included. That we can subtract it here. That is equal to 3 factorial into 2 factorial into 3 factorial. This is in that way. That will be repeated on the right side also whenever boys first. So the total we can obtain and multiply with 2 will give the answer of it. So here it is equal to, we can see that 6 can be taken out, then 24 minus, this is actually 2 into 6, 12. So 6 into 12, that is equal to 72. So here this by 72, the same will be happening this also. So the total should be what? 144. So the count is this. So you remember that there is a clubbing together. Without considering that clubbing of B1 and B2, find the count, and after clubbing together can be extra subtracted from them, will give that they will not come together, right? Now, P4 4 root 3 be a point in the parabola y square equal 4x. That will give the value for A. Look, this y square is equal to 4x. This will be lies on here. That is equal to 4, and that is a 4 root 3, the whole square is equal to 4a into 4 will give that a is equal to 3. So when a is equal to 3, it will become y square is equal to 12x. Then focus is what? 3, 0. Okay. Now any point on this curve is the form a t square, 2at. And if it is p, then you know a parabola is there. It's a focal chord P is a t square, 2at. Then this is a by t square, minus 2 by t. This. If it is P, this is Q. This is the condition. So we can see here A is what? 3. A is 3. So it is a 3t square, 6t. Then this is P. Then what is Q? Q is equal to 3 by t square, minus 6 by t. These are the condition. So you just find what is the t correspondingly given point. So we can see P 4, 4 root 3 is equal to 3t square, 6t. This provide that t. So t is equal to 4 root 3 divided by 6. That is equal to 2 by 3 root 3, or it is equal to 2 by root 3. So here P is equal to 4, 4 root 3. This implies Q becomes 3 divided by t square, that is equal to 4 by 3, minus 6 divided by 2 by root 3. So we have this point B, Q as what? 9 by 4, and here minus 3 root 3. This. And you know, S is equal to A, 0, then Z is equal to minus A, 0. So Z is equal to minus 3, 0. So using this information, we can continue the problem. So this is the parabola, and here it is a focal chord. The point P is equal to 4, 4 root 3, and this is equal to the point Q, that is equal to 9 by 4, minus 3 root 3. So there is a directrix, Z is equal to minus 3 is there. If you draw these two lines, perpendicular lines, this is PM and that is PN. You want to find the area of this PQNM. this area is required. You know, it is a trapezium. What about area? If it is L1 and L2, this is H. L1, L2. So, area is equal to 1 by 2 H into L1 plus L2 be the equation. You know, this line is parallel to x-axis. So, this length, you can easily do. What about this one? It is minus 3. So, coordinate of M is equal to minus 3 comma 4 root 3. And this N is equal to minus 3 comma minus 3 root 3. So, what is Mn? Then Mn is equal to, that's our height. Difference of that two. You know, these two are same. So, difference is 7 root 3. What is that PQ? Difference of that 2 point. You know, minus 3 and 4. This will be 4, that should be 7. And this is actually 9 minus this one. So, we can see Qn. Qn is equal to 9 by 3 minus 3. That is equal to 18 by 3. It's not 9 by 3, 9 by 4. It's 9 by 4 minus 3. That is equal to 21 by 4, right? So, this is 21 by 4 and that should be 7. So, how to find area, required area? So, required area is equal to 1 by 2 into 7 into that, adding them you got 7 plus 21 by 4. That's equal to, it is not 7 root 3. This is 7 root 3, right? So, 7 root 3 divided by 2 into, we can choose one 7 outside, then 4 plus 3 divided by 4 is there. That's equal to 7 cube root 3 divided by 2 is equal to 343 root 3 divided by 2 is the answer. 2 into 4, that is actually what? 8. This 4 into 2, it is actually 8. So, your answer is equal to third option, this one. Now, for 3 by 3 matrix M, let trace of M. Trace of M is actually sum of the diagonal elements of the matrix. Denote the sum of all diagonal elements, and A is 3 by 3 matrix and determinant A 1 by 2. Trace of A is 3 if B is the edge of 2A. This is actually very different one, and you want to find the determinant of it. Edge of adjoint of 2A. So, we need to find what is A. Look here. A into adjoint A is determinant A into I. That means edge A into adjoint of A, adjoint of edge A. Adjoint of edge A is equal to determinant of adjoint A into I. I just replace this place of A with the edge A. Now, again I am multiplying with A here, this side and that side. So, A into adjoint A into adjoint of edge A is equal to determinant of this is determinant raised to n minus 1, that is 3 minus 1. You know, determinant of edge A is equal to determinant raised to n minus 1. So, it is 3 by 3, so into I into A. So, this again, it is determinant into I into edge of adjoint of A is equal to determinant raised to 2 into A, this. That means determinant A can be cancelled from this side because I into this will be here. So, adjoint of edge A is equal to determinant A into A, this. That means, what is adjoint of 2A? It is equal to 2 determinant A into 2A, this. You know what is determinant 2 of this one? This is equal to 2 cube into determinant A into 2A. You know, this is 1 by 2. So, 2 cube into 1 by 2 into 2A implies that 8A. So, this is your B. So, when the diagonal elements of A are multiplied by 8, then trace of B is A times trace of A, which implies trace of B. So B is equal to 8A. Then trace of B is equal to 8 into trace of A. That should be 8 into trace of A is what? 3, so 24. And determinant B is equal to determinant of 8A is equal to 8 cube into determinant A. 8 cube is 512 into 1 by 2 is equal to 256. So the required sum is equal to 256 plus 24 is 280. This option 4 is there. It's actually a simple question, but we need this result. Either we can derive it or by heart it. Adjoint of adjoint is a determinant of s to n minus 2 wins on. We can keep directly this expression as a adjoint of adj A is equal to determinant of raised to n minus 2a. This result. And after we can proceed without doing this one. If you know this condition, you can easily do this. Question number 5. Suppose that the number of terms in an AP is 2k. If the sum of all odd terms of an AP is 40. You know, odd term means if initially d be the common difference, then odd term has 2d the common difference. And first term is what? A. So, in odd terms, odd k terms, A first term is A itself and d becomes 2d. So, k by 2 into A plus k minus 1 into 2d is equal to 40. So, k into A plus k minus 1 into d is equal to 40. Keep it equation number 1. Now, the next set, there is a sum of all even terms. So, the first even term is A is what? A plus d. And the common difference is again 2d. And there are k terms also there. So, its sum is equal to, that is 55 is equal to k by 2 into A plus d plus again k minus 1 into 2d is there. Is equal to that. So, we can choose 2 as a common factor and cancel here. It is equal to k into A plus d plus k d minus d is there. We can cancel this. It is equal to k into A plus k d. This is actually 55. So, there are two equations. One is this and other here. So, we can write down again them and solve for it. Given it is equal to ka plus k square minus k into d. We can put k square d minus k d is equal to 40. I just expanding this two term here, and next is ka plus k square d is equal to 55. So, when you subtracting these two, so ka and this will be cancelled. So, kd is equal to what? 15. It's one equation. And again, first term and the last term must differ by 27, which is given here. That is equal to A plus 2k minus 1 into d is the last term, minus A is equal to 27, which implies that 2kd minus d is equal to 27. So, here kd is equal to 15. We can replace here. So, 30 minus d is equal to 27. Therefore, d is equal to 3. If you replace in 3 here, k into 3 is equal to 15. Then k is equal to 5. Which is given in our first option. Now, a line L passes through two distinct points P and Q and be parallel to the vector 3i plus 2j plus 3k. If the distance of the point Q from the point R133 is 5, then the square of the area of PQ, triangle PQR is. So, you can see the equation of line. Equation of the line is equal to, the one point is there and direction is this. We can put this one as x plus 2 divided by 3 is equal to y plus 1 divided by 2 is equal to z minus 3 divided by 2. Using the point as here and ratio, direction ratio is there. Parallel to this vector means that's the direction ratio. So, we can find a general point for Q. Put them lambda, which implies that Q be the 3 lambda minus 2 and this 2 lambda minus 1 and 2 lambda plus 3 is there. Now there is a point R is given. So we can put R is equal to 1, 3, 3. So what is our distance of RQ? Given RQ is there. RQ is equal to root of difference of that means square. That is 3 lambda minus 3 the whole square. This. Plus 2 lambda minus 4 the whole square. Plus 2 lambda the whole square, which is given as 5. So we can solve for lambda. That is equal to 9 lambda square minus 18 lambda plus 9 plus 4 lambda square minus 16 lambda plus 16 plus 4 lambda square is equal to 9. So this you got at 17 lambda square. When you make the square, this is a square on 5. This will be 25. So 17 lambda square and this together it will become 34 lambda and this cancel, you got 0. This implies that lambda is equal to 0 or 2. Given lambda is positive. Sorry, when you put lambda is equal to 0, you got the same point P. They are two different points, that means we can choose other point lambda. So when you can put lambda, it will give the coordinates. When lambda is equal to 2, what is Q? Q is equal to lambda 2, Q becomes 6 minus 2, that is 4, and 4 minus 3, that is 3, and 7. This is lambda, and P is already given, that's equal to minus 2, minus 1, 3, and now we can see R. R is equal to 1, 3, 3. These are the 3 points. Now your requirement is the area of the triangles are formed. That we can see PQ. What is vector PQ? Vector PQ is equal to 6I plus 4J plus 4K. And PR, vector PR is equal to 3I plus 4J plus 0K. Now area is equal to 1 by 2 into modulus of PQ cross PR. Is equal to 1 by 2 into determinant I, J, K, 6, 4, 4, 3, 4, 0. So initially we can choose a 2 and cancel this, which will give the answer as a determinant I, J, K, 3, 2, 2 and 3, 4, 0. Now we can expand together. That is in the form I into 0 minus 8 minus j into 0 minus 6 plus k into 12 minus 6. That should be minus 8i plus 6j plus 6k. So area is equal to square root of 64 plus 36 plus 36. So root of 136. Then square of the area. So a square is equal to 136, which is given in our first option. Now question number 7. You know, limit x tending to infinity 1 plus f of x whole raised to g of x is there. It is equal to e raised to limit x tending to infinity f of x into g of x. This we can be applied. So here you want to simplify the expression this two. After we can applying limit. So we can see that expression as e by 1 minus e into 1 plus x minus ex divided by e into 1 plus x. Whole raised to x is there. So we can cancel this two term and which will be in the form 1 plus x into 1 minus e divided by 1 minus e into 1 plus x, all raised to x. So I wish to adjust this two. It is equal in the form 1 minus e plus x into 1 minus e plus e all divided by 1 minus e into 1 plus x, the whole raised to x. I just subtract an e and add here balance. So we can choose this expression be a common factor. This is 1 minus e into 1 plus x plus e all divided by 1 minus e into 1 plus x raised to x. So now you separately divide. When you separately divide, it will give that 1 plus e divided by 1 plus e into, 1 minus e into 1 minus e into 1 plus x, the whole raised to x. And when you want to find the limit extending infinity, then you come to this rule. So here, this is actually f of x, this, and this is g of x. So what is the answer? So this is equal to e raised to limit extending infinity f of x into, that is e divided by 1 minus e into 1 plus x raised to x. Look here, if we can choose as an x as a common factor here, that we can cancel. So this implies in the form e raised to limit extending to infinity e divided by 1 minus e into x divided by x into 1 plus 1 by x. So this get cancelled, and applying them, this is 0, you got only this one. So it is equal to e raised to e by 1 minus e, which is given as alpha, given. And your final answer is required with the log alpha and that. You want to find log alpha to the base e divided by 1 plus log alpha to the base e. So that's very simple. You know, log alpha, what is log alpha? Log alpha is equal to e by 1 plus 1 minus e. This is log alpha. This is log alpha. So what is 1 plus log alpha? 1 plus log alpha is equal to 1 plus e by 1 minus e, that is equal to 1 minus e plus e divided by 1 minus e will be 1 by 1 minus e. Now you want to divide log of alpha divided by 1 plus log alpha is equal to e divided by 1 minus e divided by 1 by 1 minus e is equal to e, which is given in our first option. So converting this suitably, actually it is a difficult problem. Converting them suitably is very important. You can see whenever you can feel this power is x and there is a function inside them, it will react like this. 1 plus f of x raised to g of x is take the product and take this limit. So by keeping them, you go to the right side and simplify them directly, and there is an expression we can dividing them and finding that one inside there. This is the situation. Otherwise, you can subtracting one and simplify them will give the answer also there. That we can see it like this. Limit extending to a f of x raised to g of x. Then answer is e raised to limit extending to a f of x minus 1 into g of x is applied. So you choose this one and subtracting one along with them, we can see it is actually in the form of this expression. So good. Okay. Now question number 8. Let f of x is equal to 0 to square t square minus 80 plus 15 by e raised to t dt. Then the number of local maxima and local minima of f respectively are there. How many local maxima and how many local minima is there? So you want to find the derivative. F dash x is simply using Leibniz rule. That means we can replace s square with all times. You got that x raised to 4 replacing t square with s square minus 8 x square plus 15 divided by e raised to x square. You can see put f dash x equal to 0 into 2x is important. Derivative of this x square, this x square. So f dash x square means this s square minus 3 into x square minus 5, factorizing this one into 2x. Denominator never becomes equal to 0. This implies that x is equal to 0 and x square is equal to 3 and x square is equal to 25. This square is equal to 5, right? That means x is equal to 0, then x is equal to plus or minus root 3 and x is equal to plus or minus root 5. So it is good to identifying them by simply draw a line and mark them in order. Minus root 5, minus root 3, 0, root 3 and root 5. Because of all the expressions are positive, right end should be what? Positive. So here it is positive, then negative, then positive, then negative, then positive, then negative. So f dash x undergoes a sign change from positive to negative will provide a maxima, while negative to positive is a minima. So initially this is negative to positive. So this value will give you minima. This is minima and here it is minima, here it is minima. And other two. So maximum, positive negative is maximum, this is also maximum. So 2 points are maximum and 3 points are minimum. You want to find number of local maxima are 2 and local minima are 3. So this is option there. Okay. So Leibniz rule is applied and put them to 0 and solve for this one and using wave curve procedure, and we can identify the sign and observing the count. It's a simple question. Now question number 9. The perpendicular distance of the line x minus 1 divided by 2 equal to y plus 2 divided by minus 1 equal to 2 plus 3 by 2 from a point 2 minus 10 1 is perpendicular distance of, any point on the line is, we can choose it as q as in the form 2 lambda plus 1 minus lambda minus 2 and 2 lambda minus 3, be any point. And we can keep our PV here as a 2 minus 10 minus 1, sorry, plus 1. So what about direction ratios? Direction ratios of PQ is very simple. It is in the form, this 2 lambda minus 1 and here it is equal to minus lambda plus 8 and this here it is 2 lambda minus 4. This is a direction ratio. But this PQ is perpendicular to the line. That means the direction ratio of line are 2 minus 1, 2. So we can see the product should be what? 0. So we can see it is equal to 4 lambda minus 2 plus lambda minus 8 plus 4 lambda minus 8 is equal to 0. That allowed to find the value for lambda. What about lambda? 9 lambda minus 18 equals 0 implies what? Lambda equal to 2. If it is lambda equal to 2, we can see our point becomes q becomes lambda is equal to 2 there, it is equal to 5, then minus 4 and then 4 minus 3, 1. And already you know that P is equal to 2 minus 10, 1. So we can easily find the distance PQ. PQ is equal to root of 5 minus to the cos square 3 square 9 plus here it is equal to 6 square. It is equal to root 45. It is equal to 3 root 5. So this is a simple way to find this one. Okay. So it is again a simple question. 3 root 5, option 3 is there. Now question number 10. If x is equal to f of y is a solution of the differential equation 1 plus y square plus x into 2 e raised to tan inverse y into d y by d is equal to 0. Listen, only one x variable is there. Whenever it is only one x variable and rest of them are y, it is a linear equation variable x. That is in the form dx by dy plus some p of y into x is equal to q of y form. This is the form of linear differential equation, but the variable is x. So we can dividing first of all with 1 plus y square into dx by dy plus x. Shift them to right side as 2 e raised to tan inverse y. Now dividing by this one, it will give you dx by dy plus x by 1 plus y square is equal to 2 e raised to tan inverse y divided by 1 plus y square. So our form is attained. Then you can find integrating factor. How to find integrating factor? We can see integral p of y dy is equal to integral 1 by 1 plus y square dy. It is equal to tan inverse y. Therefore, if is equal to e raised to tan inverse y. So solution is x into e raised to tan inverse y is equal to integral 2 e raised to tan inverse y divided by 1 plus y square into e raised to tan inverse y dy. Now we can start to integrating this one. It is equal to integral e raised to 2 tan inverse y divided by 1 plus y square dy. There is a 2 also here. So when you replacing tan inverse y as t, this become dy. So this is equal to integral 2 e raised to 2t dt, which will be in the form 2 e raised to 2t divided by 2 plus c. So 2 get cancelled. So your form becomes x into e raised to t is equal to e raised to 2t plus c Now there is a condition. When x is equal to 0, f of 0 is equal to 1. That means y is equal to 1. Here you can see y is 0 and x is 1. This is the condition. Given that this we can replace the form as x into e raised to tan inverse y is equal to e raised to tan inverse y plus c. Given x is equal to f of y and f of 0 is equal to at 1. This. So, do not make any confusion. As per the form, x is equal to f of y is there and f of 0 equal to 1 means what? When y is equal to 0, x is equal to 1. That means we can replace this expression as this x. Look, this is your x and that is your y. So, 1 into e raised to tan inverse 0 is equal to e raised to 2 tan inverse 0 plus c. So, this is 1 is equal to 1 plus c implies that c equals 0. That implies your c out and x is equal to e raised to tan inverse y. That means again f of, that means you replacing y with it 1 by root 3. What is your x? So, x is equal to e raised to tan inverse 1 by root 3. You know, tan inverse 1 by root 3 is what? E raised to pi by 6. So, this is x. Your requirement is f of 1 by root 3 as per x is equal to f of y. So, the confusion is the initial statement as x is equal to f of y. Usually, you are practiced to do y is equal to f of x form. Then you are thinking what about that y when you are replacing x as. That is a wrong aspect. Then you can replace them directly in the form you got x is equal to e raised to pi by 6 and that will be given in our fourth option. Now, question number 11. This is very famous form. You know, integral e raised to x into f of x plus f dash x dx is there. Then this implies that e raised to x into f of x. Now, you read the problem. Here e raised to x is there and 3 expressions are there. One is x sin inverse x divided by root 1 minus square plus sin inverse x divided by 1 minus square is 3 by 2 plus x by 1 minus square. Then you automatically think about them. This is actually, sometimes it may work. For that you keep this is f of x. Can keep this is f of x and check them if this all becomes f dash x or not. If it is f dash x, then problem is okay. Otherwise, it's actually a lengthy process to find. So, I come back to this one as finding let f of x is equal to x sin inverse x divided by root 1 minus square. So, we can apply f dash x by using symbol. So, f dash x is equal to quotient rule root 1 minus square into product rule of this x by root 1 minus square, that is x into derivative of sin inverse x plus sin inverse x into 1 minus x sin inverse x into 1 by 2 root of 1 minus square into minus 2x. So, problem is there is one more denominator, that is equal to 1 minus x the whole square, right? That root will leave. Now, you want to proceed. How to proceed there? Initially, you can expand along with them. That is actually cancelled here x plus only root 1 minus square into sin inverse x. Here we can see 2 get cancelled plus x square sin inverse x divided by root 1 minus square, all divided by 1 minus square. So, separately divide by 1 minus square, that will give the answer as x divided by 1 minus square plus this will become sin inverse x divided by, when you are dividing them, 1 cancel and you get 1 minus square there plus here it is x square into sin inverse x divided by, this will become 1 minus square raised to 3 by 2. Now, there is a single term we can clubbing together as what? X by 1 minus square plus when you splitting here as a single term of 1 minus square is 3 by 2, then 1 minus square should be here with the sin inverse x along plus x square sin inverse x. So, it is actually cancelled, the got only sin inverse x is there, x divided by 1 minus square plus sin inverse x divided by 1 minus square raised to 3 by 2. Like this, that we can easily do initially. When you have this two term, take the LCM of that two, this. when you make the LCM as x plus it is actually 1 minus x square sin inverse x plus x square sin inverse x divided by root 1 minus x square. Then you can see this is x plus simply sin inverse x divided by root 1 minus x square divided by 1 minus x square is that. Now we can divide them, it will give that x by 1 minus x square plus sin inverse x divided by that 1 minus x square raised to 3 by 2. So that will give the derivative form here finally. So problem is integral e raised to x into x sin inverse x divided by root 1 minus x square plus second thing is d by dx of this entire expression here. So the answer is equal simply e raised to x into x sin inverse x divided by root 1 minus x square. This. But you know, this is actually an integration inside them. This will be referred with the c. So our g of x is equal to e raised to x into sin inverse x divided by root 1 minus x square. So what is g of 1 by 2? G of 1 by 2 is e raised to 1 by 2 into 1 by 2 into sin inverse 1 by 2 divided by root of 1 minus 1 by 4. So we can simplify this. E raised to 1 by 2 is equal to root e into this is 1 by 2 and sin inverse 1 by 2 is pi by 6. All divided by this is root 3 by 2. So 2 get cancelled. That's equal to pi by 6 into root of e by 3 is the answer. So this final answer is actually a confused form. So pi by 6 into root of e by 3. Third option is the correct answer. Now question number 12. Let alpha theta and beta theta be the distinct roots of this equation 2x square plus cos theta x minus 1 where theta belongs to 0, 2 pi. If m and capital M are minimum and maximum values of that theta raised to 4, alpha raised to 4 plus beta raised to 4, then what is 16m plus m is the value. So you can ignore that theta. We can see that alpha plus beta. I put that alpha is, this is alpha and that is beta. So alpha plus beta is equal to, by using quadratic equation, is what? Minus cos theta divided by 2. And alpha beta is equal to minus 1 by 2. Then you can see your requirement is alpha square, not alpha square, alpha raised to 4 plus beta raised to 4. So from this equation you can see alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta. Because of these two are given, this we can transcend the form cos square theta by 4 minus 2 into minus 1 by 2. That's equal to cos square theta by 4 plus 1. This is alpha square plus beta square. So what about this one? This again, this is equal to alpha square plus beta square the whole square minus 2 alpha square beta square. So this expression is cos square theta by 4 the whole square plus 1 the whole square minus 2 into square of that alpha square beta square is 1 by 4. That implies cos square theta by 4 plus 1 the whole square minus 1 by 2. This is our expression for alpha square 4 by theta plus beta raised to 4 theta. Now depending on theta, the maximum and the minimum value will vary. But you know, here it is cos square theta. Cos square theta is always what? Non-negative. So its minimum value should be 0 and maximum value should be 1. So this is the expression here. So we can see, we can improve with the 0 is applied for minimum value and 1 we applied for maximum value, and simplifying it will give the answer of it. So because of that theta square, you can see when this is actually with the pi by 2 0, that is equal to 0. M is equal to 0 by 4 plus 1 the whole square minus 1 by 2 is equal to what? 1 by 2. And capital M is maximum, that is equal, you can see it is 1 by 4. 1 is the maximum value here. 1 by 4 plus 4 is equal to 5 by 4 the whole square minus 1 by 2. That is equal to 25 by 16 minus 1 by 2. That is equal to 17 divided by 16. So we have two values. Now you want to find 16 times L plus M. Therefore 16 into m plus capital M is equal to 16 into this is 1 by 2 and that is 17 by 16. So open this equal 18 plus 17 is equal to 25. So option 2 is there. Now question number 13. Let A is equal to set 1, 2, 3, 4 and B is equal to 1, 4, 9, 16. Then the number of minimum function from fa to b such that 1 belongs to f of a. It should guarantee that 1 always be in f of a. It's actually a confused problem. First of all, how to find minimum function? You know, the number of function is what? Number of b raised to number of a. This is actually function from a to b. Number of function from a to b is this. So here both of them are 4 each. So it is equal to 4 is to 4. This is number of functions, 4 is to 4. But at the same time, how to find minimum function? You know, it is easier to find number of one-to-one function. Number of one-to-one function is NPN form, seal and factorial. Number of one-to-one function should be what? We can permit this all, n elements to n each. That is actually NPN. So that will give the 10 factorial form. But that include that all n, all 1 also inside that because of this condition 1 is there. So when you subtract this 2, that is actually 4 is to 4 minus 4 factorial. 4 is to 4 means it is equal to 16 square minus 24. 256 minus 24, that is equal to 232. There are 232 such functions, minimum functions are there. But actually problem contain that 232 should involve with 1. So we can search how many such functions are there without the number 1. That can be removed from it, will give the answer of it. Why? Because there is no one-to-one function without that one. This is the condition. Because of equal number of that a and b, all one-to-one functions should contain that exactly 1. So there is not a problem there. You can remove this minimum function by simply subtracting how many functions are there without 1. Only this count can be adjusted. How we can make the adjustment? By simply keeping this one as what? A contains 4 and B contain having no elements. The number of functions without 1. Without 1 there is no one-to-one. So there is not a problem for that. How many of them have not that one? That we can choose it as what? 3 raised to 4. Because here it is 3 without 1 and there is 4. So 3 raised to 4 is what? That is equal to 3 square, 81, right. So 81 of them are functions in there without that. So with this means what? We can exclude this without that element from the amount. That include with all containing this one. So the required count is equal to, this is actually what? This is without 1, we can framing the functions and among them the count is there. So the required number is equal to 232 minus the function without that one, that is equal to 81, is equal to 1 and 4 and 5 and 1. 151 is there. So x correct. So there is a number 151 is there. So you can think because of equal number is there, without 1 there is no 1 1. So we confirm them. These are minimum that exactly with the minimum means that minimum contains some functions are there having no 1 is there. So they are actually functions along with the initial pattern. You just find how many of them are belongs to the other function existing 1 as included, which will providing you the form. Just you exclude that one and remaining 3 should be there and that should make the function with the count as 3 raised to 4. That should be 81. You subtract that 81 function from this total count of minimum function will give the correct function as per the question. It's actually a confused one. This question number 14. The system of linear equation x, y, 2x, etc. Look here, I shall give initially without doing this problem. You can see suppose x plus y plus 2z is equal to 6. I think that the problems are having x is equal to 1, y is equal to 1 and z is equal to satisfactory, right? I put another question is there, 3x plus 2y plus z. You know, as per the condition, it is equal to 5 plus 2, 7. Now, I just add this together. What we can 4x plus 3y plus 3z is equal to 13. Look here. Here there is actually two equations there. And I just take the sum here and write down this. Definitely you can see there are only two equations. This is an extra equation is obtained by that two. What happened to correct form? This is 1, 1, 2, 6. I just take that coefficients of 1, 1, 1 and that 6 there. Then 3, 2, 1, 7. And here it is 4, 3, 3, 13. Look this. While I reduce the form by row reduction procedure to keeping the condition, you can see it is very simple. I just multiplying this 3 and subtracting here by keeping these two are zeros. Look here what I did. I just multiplying with the 3 here and subtracting here. That is actually 3, 2, 1, 7 and multiplying by 3 will give you 3 and 6 and 18. Now I subtract here 3 minus 3 is equal to 0. Then minus 1, minus 5 and what? Minus 11. It may be written 0, 1, 5, 11. No problem. Again the second one. Second one I subtracted here 4, 3, 3, 13 and multiplying with the 4. That is equal to 4, 4, 8 and 24. Now I subtract here, that is equal to 0. Then again I subtract in this way 1 and that is 5. Then what? It is equal to 11. So I got again 0, 1, 5, 11, 11. So when I report this one, 1, 2, 1, 1, 2 and 6 is the first one. This will cost to 0, 1, 5 and 11 and this will cost to 0, 1, 5 and 11. Now I wish to reduce this expression by this pattern. What happened that then when you are subtracting these two rows, it will give you 1, 1, 2 and 6. Then 0, 1, 5 and 11. Then 0, 0, 0 and 0. This is actually wherever you have an infinite number of solutions, we can reduce the pattern in this form. So this is a modern technique to identifying this type problem. Look this, if you have a matrix like this, then you write down the form. Then whenever you can reduce the pattern, I shall explain the reduced pattern here. That's actually first element should be A, B, C and that D. Second should be 0, some B, 1 and C, 1 and here it is A1, 1, 1, then B2, C2, then D2. Then last one is 0, 0 and C3 and D3. This is the converting form. You keep these three elements are 0 in this pattern. Now look this, I shall explain to you there. If C3 not equal to 0, then the determinant exists, then it is unique solution. If C3 not equal to 0, system is unique solution. And C3 is equal to 0 and D3 is not equal to 0, no solution. This is the second condition. Look here, this 3 are 0 but this is not equal to 0, then no solution. You blind write down there. And C3 equal to 0 and D3 equal to 0, then infinitely many solution. These are the three category. Look here, by reducing our usual pattern to find a row reduction procedure, you can keep this element is here and below here it is 0 and these two are there and these two are zeros. This is the conversion initially, and after simply observing the last row, we can say whether it is a consistent or inconsistent or infinitely many solution like that. The conclusion is this: if C3 are not equal to 0, unique solution. When C3 equal to 0, check to D3. If C3 and D3 are 0, infinitely many, C3 0 and D3 not equal to 0, no solution. Please keep this way and I shall easily answer this question. Here 1, 1, 2 and 6. Then 2, 3, A and A plus 1. And minus 1. This is good by minus by multiplying with the 1. That is 1, 3 minus B and minus 2. This is good. Now keep in mind, you can reduce these two are zeros first. How you can reduce some 0? Keep that first one be there, 1, 1, 2, 6. Then multiplying by 2 and subtract, that is equal to 0. You know, if you have a confusion, you write down like this. 2, 3, a plus 1 and multiplying by 2, that is equal to 2, 2, 4, 12. Subtract, it will become 0, then 1, a minus 4 and a minus 11. This is our second row. 0, 1, a minus 4 and a minus 11. Now you come to this one becomes 0. That is what 1, 3, minus b, minus 2b, and below 1, 1, 2 and 6. Then you can see 0, 2, minus b, minus 2 and minus 2b, minus 6. So here it is, we can return as 0, 2, minus b, minus 2 and minus 2b, minus 6. This. So first stage. Now only one more step is required to complete in this one is 0. How to complete in this one is 0? It's very simple. Just to multiply this 2 and subtract here. So I just write down here as 0. I just multiply by 2 here, that is 0, 2, 2a minus 8 and 2a minus 11. Below here 0, 2, minus b minus 2 and minus 2b minus 6. Now you subtract 0, here 0, no problem whether it is subtracted from above to below or below to above. So here it is equal to 2a plus b minus 6 and here it is equal to 2a plus 2b minus 5. So these are our third step. So you have the form 1, 1, 2, 6 and second is 0, 1, a minus 4, a minus 11 and the last is 0, 0, 2a plus b minus 6 and 2a plus 2b minus 5. Look this. You have a determinant. Then what is our information? So this type questions are there. You want to find infinitely many solutions. For infinitely many solutions, what is the condition we told? It is what? Both of them are 0. That means these two are 0. For infinitely many solutions, we can write down this 2a plus b minus 6 equal to 0 or equal to 6 and 2a plus 2b is equal to what? 5. So subtract, it will give you minus b is equal to 1 or b is equal to minus 1. I made a small mistake here. When you multiply by 2, here it is not 11, it is what? 22. So when you are subtracting this 22 minus 6 is what? Minus 16. So this is actually what? It is a 16 is there. So when you are subtracting, here it is equal to minus 10, therefore b is equal to 10. This is correct. When b is equal to 10, replacing here 2a plus 10 is equal to 6 or 2a is equal to minus 4, then a equal to minus 2. So here a is equal to minus 2 and b is equal to 6 will give the condition. B is equal to 10, not 6. B is equal to 10 will give the condition for infinitely many solution. Now we can find the requirement. If that condition is there, we can find 7 into minus 2 plus 3 into 10. It will give the answer of 7 into minus 2 plus 3 into 10. That is equal to 14 plus 30 with the minus sign. So it is equal to 16. So option 3 is there. Let a bar and b bar be two unit vectors such that angle between them is pi by 3. If lambda a plus 2 b bar and 3a minus lambda b bar are perpendicular to each other, then the number of values of lambda in minus 1 comma 3 is obtained. It's a simple question. You know, a bar dot b bar is equal to what? 1 into cos pi by 3 is 1 by 2. It's equal to 0.5 or 1 by 2. And lambda a bar plus 2 b bar dot 3 a bar minus lambda b bar is what? 0. So, you know, a bar dot a bar is 1 unit vector, b bar dot b bar is equal to 1 and a bar dot b bar is now it is what? 1 by 2. So, open this one here, you can see it is 3 lambda into 1 minus lambda square into 1 by 2. Again plus 6 into 1 by 2 minus 2 lambda is equal to 0. This is the condition. So multiplying by 2 will give that 6 lambda minus lambda square plus 6 minus 4 lambda is equal to 0. That is equal to minus lambda square plus 2 lambda plus 6 equals 0. So, lambda square minus 2 lambda minus 6 equals 0. So, it is best we can find directly what is lambda. So, lambda is equal to 2 plus or minus root of 4 plus 24 divided by 2. That is equal to 2 plus or minus root of 28. That is equal to 2 root 7 divided by 28. That is equal to 1 plus or minus root 7. So, your problem is how many such values are in between that two. So, one is 1 minus root 7 and other is 1 plus root 7. You know, root 7 is less than 3 and more than 2. So, 3 less than 1 plus root 7 less than 4. So, 1 plus root 7 is beyond that 3. So, that is not included. Now, the next one. Here we can put that minus 3 is less than minus root 7 less than minus 2 multiplying by minus sign. Adding 2, this is minus 2 less than 1 minus root 7 less than minus 1. So, 1 minus root 7 is less than minus 1 and 1 plus root 7 is greater than 3. So, there is no root inside that value for lambda. So, the correct answer is 4. So, it is very interesting. No need of finding root 7. Just you locate that value for root 7. You know that root 7 is what? It is lies between 4 and 9. So, it is lies between 2 and 3. Then we can locate the value by adding 1. It is beyond that 3 and before that minus 1. So, it is excluded. Now, question number 16. There is an ellipse x square by a square plus y square by b square equal 1. A is more than b. Hyperbola x square by a square minus y square by b square equal 1. The distance between the foci of ellipse and that of foci of hyperbola are 2 root 3. And a minus capital is 2. The ratio of eccentricities of E and H is 1 by 3. Then the sum of the length of their lattice rectum is. So, sum of the length of lattice rectum is 1 is 2b square divided by A because A is more. And other is 2b square divided by A. That is not a problem. This is our requirement. Now, as per the first one, distance between the foci that is equal to 2AE is equal to 2 root 3 means AE is equal to root 3. Same for hyperbola also. So, 2 capital AE dash is equal to 2 root 3. That is AE dash is equal to root 3. Therefore, AE divided by AE dash is equal to 1. Given ratio of the eccentricities are 1 by E2, that is equal to E divided by E dash is equal to 1 by 3, which implies that A by A is equal to E dash by E or it is equal to 3 or A is equal to 3A. This is the condition. And at the same time, A minus 3A is given. So, A minus A equal to 2, we can replace with A as 3A. So, 3A minus A is equal to 2 or we can see A is equal to 1. So, when A is equal to 1, capital A is equal to 1, then small a is equal to what? 3. That will observe. That means B square is equal to, sorry, I think that is best we can using that AE. You know, AE is equal to root 3. This root of A square minus B square is also root 3. So, A is 3 means A square minus B square is equal to 3. Then 9 minus 3 is equal to B square. This implies that B square is equal to what? 6. So, B square is okay. Again, A square plus B square is equal to square of 3. That is actually 3. And A square is given as 1. So, 1 plus B square is equal to 3. Implies that B square is equal to 2. Now, come back to the sum. Requirement is 2b square by A. That is equal to 2 into B square is equal to 6 divided by A is equal to 3 plus 2 into B square is equal to 2 divided by A is equal to 1. So it will give you the answer as 2. 4 plus 4 is 8. So inside the option is 8. So it's also a tricky question, but we proceed them with the knowledge of this all ellipse and hyperbola. We can easily find this two. Okay. Now the next one, A and B are two events such that P of A intersection B equal to 0.1 and P of A given B and P of B given A are the roots of 12 square minus 7x plus 1 equal to 0. So we can think any one of them be that root. So P of A given B is equal to 7 by 12 and P of B given A is equal to what? 1 by 12. So this is very simple. Are the roots means the sum. Here it is equal P of B given A plus and here P of B A given B into this. So product is 1 by 12 and the sum is 7 by 2. They are what? 1 by 3 and 1 by 4. We can see this is equal 1 by 3 into 1 by 4 and this is equal 1 by 3 plus 1 by 4. So I think that there is no need of simplifying to directly observing it. We can easily observe that two number. That we can see P of A, suppose P of A given B is equal to 1 by 3. Then P of B given A is what? B of B given A is equal what? 1 by 4. Now listen, what is P of A given B? P of A given B is equal to P of A intersection B divided by P of B, which is equal to what? 1 by 3. That means 3 into P of A intersection B is equal to P of B. It is given as 0.1. So P of B is equal to what? 0.3. So what is P of A? See me 0.4. So we can see P of A and P of B are given and P of A intersection B is also given. And P of A intersection B is 0.1. Now we come to this one. What is P of A union B, A dash union B dash divided by P of, that's our requirement, A dash intersection B dash. This will be written as in the form P of A intersection B all dash divided by P of A union B all dash. So that's equal to 1 minus P of A intersection B, you know the number, divided by this is equal to 1 minus of P of A plus P of B minus P of A intersection B. You know this all. It is equal to 1 minus 0.1 divided by 1 minus 0.3 plus 0.4 minus 0.1. That is equal to 0.9 divided by, this we can see 1 minus 0.6 is equal to 9 by 4. So option 3 is there. So this is actually a tricky question, we can easily answer it. Now the sum of all values of theta in 0, 2 pi satisfying 2 sin square theta is equal to cos 2 theta and 2 cos square theta is equal to 3 sin theta. You know 2 sin square theta. What is cos theta into sin? 1 minus 2 sin square theta. So for sin square theta is equal to 1 or sin theta is equal to plus or minus 1 by 2. This is the condition. First one is there. And second one, 2 cos square theta, that's equal to 2 into 1 minus sin square theta is equal to 3 sin theta, which implies that 2 minus 2 sin square theta is equal to 3 sin theta. Therefore 2 sin square theta plus 3 sin theta minus 2 equals 0. So product is minus 4, sum is 3, it will give transfer from 2 sin square theta plus 4 sin theta minus sin theta minus 2 equals 0. So we can see this is 2 sin theta into sin theta plus 2 minus sin theta plus 2 is equal to 0. That is equal to sin theta plus 2 into 2 sin theta minus 1 is equal to 0, implies 2 sin theta is equal to 1. But this is not happen. That is actually sin theta is equal to 1 by 2. So here two conditions. Initially sin theta is equal to plus or minus 1 by 2 is there. Now you can see sin theta equal to 1 by 2. And read carefully the question. And or not a problem. If it is and, it is simultaneously happen both. That means only one expression can be accepted. Sin theta equal 1 by 2. So you know, whenever you draw the graph, this is sin theta graph. And up to this one is 2 pi. And this is actually pi and here it is 0. Then 1 by 2 tell us this value. This is actually what? Pi by 6. What about this? This number is pi minus pi by 6. Looks no need of 5 pi by 6 is written. If it is more, that should be either 2 pi plus or 3 pi minus. And when you want to find a sum, is easily there. You want to find a sum, but we can pi by 6 plus pi minus pi by 6. Then this get cancelled. You got the number pi. If it is more divisions of 0 to 2 pi or 0 to 8 pi, the sign values should be what? 0 to pi, then 2 pi plus 3 pi plus etc. like this. We can cancel that all pi values initial and you got the multiples of pi is there. Okay. So here the option fourth option with the correct answer. Now the next question. Z into 1 plus I plus Z bar into 1 minus I. You know the conjugate of Z is Z bar and that of 1 minus I is this. So suppose we can keep Z1 is equal to Z into 1 plus I. Then Z bar into 1 minus I is simply what? Z1 bar. So Z plus Z1 bar is equal to 4 is there. This is actually what? Real part of Z1 is equal to 4. This is the requirement. So as per the condition, this is actually real part of Z1 is there. What is real part of Z1? You can see this we can transform in the form x plus iy into 1 plus I. Then real part of Z1, this is your Z1. Real part is what? X into 1, that is x. And this is 2 real part of Z. Therefore, real part of Z is what? Simply 2 is there. So here it is x into 1 and minus I into I is minus y. This is only real part. Rest of them are imaginary part. So the equation is x minus y equal to 2 is there. It's a straight line. Now what about that mod z minus 3 less than 1? So it's a circle whose radius is 1 unit. Then it is subdivided into 2 regions and you want to find the region, the area. So we can graphically do the situation. So this is a circle whose center at 3 and radius is 1 unit this. And y is x minus 2. What is y? This is actually what? This point is 2, 0. This is also a point on the circle. And here it is equal to what? 0 minus 2. So this is the line. So what about the point of intersection with this circle? You know, x minus 3 the whole square plus y square is equal to 1 unit. That is actually 1. And y is equal to x minus 2 is there. That is x minus 3 the whole square plus y minus 2 the x minus 2 the whole square equal to 1 is there. Spanning you got that x square minus 6x plus 9 plus x square minus 4x plus 4 minus 1 equal to 0, which will give you 2x square minus 10x plus 12 is equal to 0. That is x square minus 5x plus 6 equals 0. So x is equal to 2, 3. You know, 2 is there, 3 is this point. So the point of intersection has 3 is there. When you put 3 in here, x is 3, 3 minus y is 2 means what? It is 1 unit. So this point is 3, 1. So now it is very interesting. There is a circle. You can see there are 2 regions. One region is this. We refer as alpha. And the other region is this one. We can refer this. One is alpha. If you can put this, it is equal to alpha. If it is alpha. And this is beta. How we can, you want to find the difference of alpha and beta. But what is beta? You can see beta is equal to total area because unit radius, it is pi minus alpha is there. That means alpha minus beta is equal to this is equal to what? Alpha minus of pi minus alpha. That is equal to 2 alpha minus pi. Modulus of alpha minus beta we can transfer either this or pi minus 2. Which one is more? That we can see. This modulus of that. Pi minus 2 alpha or there. Then the problem is very simple. You can see. What is that alpha? You can see this is a quarter of the circle and subtracting this triangle's area. This is the quarter of the circle. What is the quarter of the circle? Quarter of the circle is alpha is equal to pi by 4. This is pi by 4. Minus area of this triangle. Did you know? 2 and 3. This is 1. Here also 1. That's actually what? 1 by 2. This is alpha. Therefore, what is 2 alpha? Look this, here it is 2 alpha. So, it is equal to pi by 2 minus 1. So, 2 alpha is pi by 2 minus 1. What is the modulus of alpha minus beta? Modulus of alpha minus beta is equal to pi minus alpha pi by 2 minus 1. So, it is equal to pi minus pi by 2 plus 1. That is equal to 1 plus pi by 2. So, our required answer is 1 plus pi by 2, and that should be this first option. So, logically you can think what actually happened with our complex form and converting the figure and think what are the difference of that two and how we can relating this with the area of a circle and the region with the triangle like that. There is no need of integration is applied. Now, the area of a region enclosed by the curves y is equal to x minus 4x plus 4 and y square is equal to 16 minus 2x. Look here, your requirement is area. Here also what? Y is equal to x minus 2, the whole square is a curve, and other one is y is equal to minus 8 into x minus 2. When you shift the problem as y is equal to x square and y is equal to minus 8x, no problem, because we are searching area. Area between two parabola. Listen, whether two parabola like this, one is actually in this form and other is actually in this form, then area between two parabola will be this one, this region. If it is in the form y square is equal to 4x and x square is equal to 4bx, the way is there, you just solve this to point of intersection, and from here to there subtract this 2 will give the answer. That is actually lengthy. But what may be the situation when you studied in your material, in your problem, this is actually what 16 AB divided by 3, please keep that way. Otherwise, that is time consuming. You know, while you are facing to write down this type exam, we can't complete more questions in mathematics, because what you are thinking, if there is an area problem is there, then we can do with the integration, and after we can finding the form as y1 and y2 as integration form, solving it, etc. So, here they traditionally providing the form as area between this one is what? 16 AB divided by 3. This is the good condition for this y square equal 4x and that. Now, look this, negative sign is not a problem. Your 4b is a 1, this is actually y. So, for one is a y is equal to square and other is a, I put down is the form, this, okay, sorry, that's actually the form y square equal to 4x and y square is equal to 4bx. So, not problem for using this condition with the b and that. You can say 4b, modulus 4b is equal to what? It is equal to 8 and 4a is what? It is equal to 1. So, take this one is 4a into 4b divided by 3. That's equal to 1 into 8 divided by 3. Answer is 8 by 3. So, over. So, shifting of the problem is not a problem, and at the same time using this condition, you know, this is actually lattice rectum here. So, 16AB is what? 4a into 4b divided by 3. So, you can see this two number will be given 16 and by 3 is there. This 3 is obtained by integration. So, I strongly recommend this formula directly and we can use the answer of it. Okay. Now, question number 21. Let y is equal f of x be the solution of the differential equation dy by dx plus xy by root x square minus 1 and x raised to 6 plus 4x divided by root of 1 minus s square. Look this, root of 1 minus s square, and this will condition for that x lies between 1 and minus 1. So, when you find this is a linear equation with the p is equal to x divided by x square minus 1. So, when you find the integral of p dx, it is equal in the form 1 by 2 log mod x square minus 1. This we can identify. You know, mod means what? This is never negative. So, it should be reversed as in the form 1 by 2 into log of 1 minus x square, because x lies between 1 and minus 1. So, this is equal to log of root 1 minus x square is there. So, what is IF? IF is equal to e raised to log of root 1 minus x square is simply root 1 minus x square. So, solution is y into root of 1 minus x square is equal to integral x raised to 6 plus 4x, because that get cancelled by this root 1 minus x square. Now, we can easily integrating it. That's equal to y into root of 1 minus x square is equal to x raised 7 divided by 7 plus 4 x square divided by 2 plus c. Look this, f0 equals 0 means when you are replacing 0 as x, then y also 0. So this time get cancelled, these two are so there, then f0 equals 0 implies c equals 0. So your problem reduced to c out and y becomes x raised to 7 divided by 7 root 1 minus x square plus 2x square divided by root of 1 minus x square solely. This is y. Then what do you want? This is your f of x. Then your requirement is a area integral, a is equal integral minus 1 by 2 to 1 by 2 f of x dx, which will be in the form integral minus 1 by 2 to 1 by 2 x raised to 7 divided by 7 into root of 1 minus x square plus 2x square divided by root of 1 minus x square dx. Now you feel that this is a lengthy one. No, this is a odd power and this is even power. And the limit is from minus 1 by 2 to 1 by 2. So you know this is an odd function. What may be that value from minus 1 by 2 to 1 by 2 becomes 0. No need of integrating that expression. That becomes 0. But this is exists. This is actually both of them are even. So it is 2 times. So it is equal to 0 plus 2 into integral 0 to 1 by 2 into 2x square by root 1 minus x square dx. This is a form. So we are trying to integrating it. How to integrating this? It will be 4 into integral 0 to 1 by 2 x square divided by root of 1 minus x square dx. Now you think about substitution for x as what? Sin theta. When you put x sin theta, this is cos theta, and here also cos theta d theta, this is sin square theta, this become pi by 6. So this is equal to 4 into integral 0 to pi by 6 into sin square theta into cos theta d theta divided by below, this is also cos theta, we can cancel it. So there is a pi by 6 and sin square theta. How to integrating sin square theta? We can convert this one as in the form, you know, this we can transfer in the form 2 into integral 0 to pi by 6 into 2 sin square theta. We can convert this one as cos theta form. That's the thing. So it is equal to, then we can write down as in the form 2 into integral 0 to pi by 6 1 minus cos 2 theta into d theta, which will be in the form 2 into theta minus sin 2 theta divided by 2 0 to pi by 6, which will be 2 into this upper limit is pi by 6 plus 1 by 2 into, you know, sin pi by 6. What is sin pi by 6? Into 2 sin pi by 3. Sin pi by 3 is root 3 by 2. So into root 3 divided by 2. So when you multiply with 2, it is equal to pi by 6 become what? Pi by 3 plus root 3 by 2. So here there is a minus sign is there. It is integral minus 1 by 2 to 1 by 2 f of x dx. But your requirement is 6 times integral minus 1 by 2 to 1 by 2 f of x dx is equal to what? 2 pi minus alpha. So when you multiplying this one with the 6, so 6 into pi by 3 minus root 3 by 2. So we can see this is equal to 2 alpha is there, right? So only alpha is there. Okay. So it is equal to 2 pi minus 3 root 3, which implies that alpha is equal to what? 3 root 3. Your requirement is what is alpha square, that is equal to 27. It is conversion of our integer type. So 27 is the answer of here. Now question number 22. Please carefully read the question. A 6, 8 and B 10 cos alpha minus 10 sin alpha and B C minus 10 sin alpha 10 cos alpha be vertex of a triangle. Let L A comma 9 and G H comma K be its orthocenter and centroid of respectively. Then what about the sum? 5a minus 3h plus 6k plus 100 sin 2 alpha. You know, a 6, 8. Then we can see that squaring and adding that 2 should be 10. And 10 cos alpha minus 10 sin alpha. Squaring and adding sin square plus cos square is 1. So again 10 square, that is actually 10. And this also what? 10. That means this A, B, C are equidistant from the origin. That means if you draw a circle whose center at origin, here it is A and here it is B and here it is C. So they are on the same circle. So circumcenter is what? 0, 0 of the triangle is ABC. So, A9 be the orthocenter and GH be the centroid. Then you know this is actually our orthocenter and this will be circumcenter. Then you can see this will be G. You know, they are on the same line. That line is known as Euler line. And that G divide this line in the ratio 2:1. So 1:2. Here it is 1 and that should be 2. That means 2S plus 1L divided by 3 is equal to G implies 2S plus L is equal to 3G. It's one of the important result. You know, if S is origin 0, 0, it will be 0 form of 0. So L, look this, when you are replacing this coordinate as 2 into circumcenter 0, 0 plus L is what? A comma 9 is equal to 3 into H comma K, which implies you can expand this all. This is 0 plus A is A comma that is 0, that is 9. A comma 9 is equal to 3H comma 3K, which implies A is equal to 3H and 3K is equal to 9, or implies what? HK is equal to what? 3. At the same time, there are 3 given points. Then we can find centroid again. 3H comma K is sum of that what? A plus B plus C. That's equal to, we can take the sum as A 6 and 10 cos alpha minus 10 sin alpha, 8 minus 10 sin alpha plus 10 cos alpha as per our given points. We can add this coordinate. Then we have 2 more equations. What are the equations inside them? 3H is equal to 6 plus 10 cos alpha minus 10 sin alpha, and 3K is equal to 8 plus minus 10 sin alpha plus 10 cos alpha. So, these two are same. So, 3H minus 3K is equal to 9. Sorry, 2 minus 2 when you are subtracting them. It is 9. So, 3H is equal to 9 minus 2 equal to 7. So, 3H is equal to 7 means A is equal to 7. So, 3H is 7 and A is 7. These two values are there. Now, we can see how to find that this number. That's actually, you know, this is 9. So, 9 is equal to 8 plus 10 cos alpha minus 10 sin alpha. So, this become 1. So, we can see 1 square is equal to 10 square cos square alpha plus 10 square sin square alpha minus 2 into 10 square into sin alpha cos alpha. So, this is equal to 1 is equal to, this will be 100 minus 100 into 2 sin alpha. That is actually sin 2 alpha. This is, we can trans 2 sin 2 alpha, which implies that 100 sin 2 alpha is equal to 99. Subtracting 1 to there, 99. So, 100 sin 2 alpha is there. What is our requirement? Our requirement is 5A minus 3H plus 6K plus 100 sin 2 alpha. You know, 3H is equal to A. So, 5A minus A plus 6K plus 100 sin 2 alpha is there. This is 4A plus 6K plus 100 sin 2 alpha. Now, we can replace this all value. You know, A is what? 7, 28. And K is 3, that is 18. Plus this is 99. So, here it is equal to 46 and 99. So, 5 and 145. The answer is 145. Okay. Now, question number 23. Let the distance between two parallel lines be 5 units and a point P lie between the lines at a unit distance from one of them. an equilateral triangle PQR is formed such that Q lies on one of the parallel lines while R lies on the other. Then QR squared is. So, there are two different parallel lines. One parallel line is this and other parallel line is this. Given that distance between the two lines be 5 units. So, I simply draw a vertical line. This distance be what? 5 units. P lie a point between the two lines, a unit distance from one of them. I just take this one is the P. So, this is 1 unit and that is 4 units. Now, there is an equilateral triangle, 40 degree, 60 degree there. This is an equilateral triangle, that means they make a 60 degree. Here it is 60 degree. This also 60 degree. Here also 60 degree. If this one is a theta, suppose, and this is 90, then this what? 90 minus theta. Here also it is 90. So, both of them are 60 plus 90. We can see this angle is 180 minus 60 plus theta is there, 120 minus theta. This is a 120 minus theta. So, if it is alpha, sum should be 90. That is alpha plus 120 minus theta is 90. That means alpha is equal to theta minus 30. This. Here it is 1 and this is D and here also D. So, I choose what is cos theta from the figure? This triangle, 4 by D. What is sin theta minus 30? Is equal to 1 by D. So, here it is 4 and that. So, we can see by dividing both. So, cos theta divided by sin theta minus 30 is equal to 4. So, cos theta is equal to 4 into sin theta cos 30 minus cos theta sin 30. So, it is equal to 4 into sin theta into root 3 divided by 2 minus cos theta into 1 by 2 into 4. So, we can cancel here it is 2 and shift them to this side as 3 cos theta. 3 cos theta is equal to 2 root 3 sin theta. So, what is tan theta? Tan theta is equal to 3 divided by 2 root 3. So, when you draw a triangle with this one as the theta, here it is 3 and this 2 root 3. Squaring and adding, that is equal to 12 plus 9 is 21. It is root 21. So, what is cos theta? Cos theta is equal to 2 root 3 divided by root 21. That is equal to 2 divided by root 7. Which is given as 4 by D. This implies 2D is equal to 4 root 7. So, D is equal to 2 root 7. Your requirement is D square. That is actually QR. QR is the length of D. That is equal to 4 into 7 is what? 28. So, the answer side is 28 units. Now, question number 24. If 1 to 30 r square into 30 CR raised to 2 divided by 30 CR minus 1. So, we can do initially r square into 30 CR into 30 CR divided by 30 CR minus 1. This we can write as in the form r square into 30 CR into, what is 30 CR by that? It is equal to 30 minus r plus 1 divided by r. By this, you know, NCR divided by NCR minus 1 is equal to N minus r plus 1 by r. This is the formula for that. Otherwise, we can put that and find it. It is equal to 1 r get cancelled. That is still r into 31. 31 minus r into 30 cr. This. So, this is good to expand this expression and cut one more r from there. It's equal to r into 31 minus r into, this is 30 factorial divided by r factorial into 30 minus r factorial. So, again it is written as in form 31 minus r into 30 factorial divided by r minus 1 factorial into 30 minus r factorial. So, if you can keep the 30 as a common factor there, then it is equal to 31 minus r into 29 factorial divided by r minus 1 factorial into, this is actually what, 30 minus r. 30 minus r is 29 minus r minus 1 is 30 minus r. So, this is again we can express as the form 30 into 31 minus r into 29c r minus 1. This is a simplification of the entire term. So, we can proceed. This expression becomes, so sigma r is equal to 1 to 30. Instead of this, we can replace 30 into 31. 31 minus r into 29c r minus 1. This we can put into two different aspects. One is 30 into 31 and that. It is equal to 30 into 31 into sigma r is equal to 1 to 30 29 c r minus 1 minus sigma 1 to 30 r into 29 c r minus 1, and can 30 also put here. Now listen, this will be written on the same pattern by choosing the form 30 into 31 into sigma r is equal to 32 r equal to 1. Reverse, then it is 29 c r minus 1 minus 30 into sigma the same. This we can replace, only 30 can be taken out. So, this is equal to 30 into sigma r is equal to 32 r equal to 1. 31 minus r into 29 c r minus 1. Now, look this. This will be written in the form 30 into, in replacing the 30 here, 31 minus r is what? Is equal to 1 into 29 c 1. 30 minus 1 is there. Again, next term, reduce 29 is applied, that is 2 into 29 c 2 plus etc. When you are replacing 1 here, it is equal to 30 into c 0. 29 c 0. 30 into it is 29. When you are replacing 30 here, it is 29, and this will become 28. So, we can retransform in the form 30 into 1 into 29 c naught plus 2 into 29 c 1 plus etc. plus 30 into 29 c 29. This is the form. This we can transform in the form 30 into sigma r is equal to 0 to 29 r plus 1 into 29 c r. Now, we can see 1 plus x the whole raised to 29 is equal to sigma 29 c r x raised to r. I just multiply both sides with r. So, x into 1 plus x the whole raised to 29 is equal to sigma 29 c r into x raised to r plus 1. It is actually r is equal to 0 to 29. Now, differentiating both sides, that is equal to x into 29 into 1 plus x the whole is 28 plus 1 plus x the whole is to 29 into 1 is equal to sigma r is equal to 0 to 29 r plus 1 into 29 CR into x raised to r. Put x is equal to 1. This implies that 29 into 2 raised to 28 plus 2 raised to 29 is equal to sigma r is equal to 0 to 29 into this one is r plus 1 into 29 CR. So this answer is exactly here that too. We can see this is equal to 2 raised to 28 can be taken out, that is 29 plus 2 is there. That's equal to 31 into 2 raised to 28 is equal to sigma r is equal to 0 to 29 into r plus 1 into 29 CR. Now we can replace this number inside this expression. This expression. That's our final answer. This. So your answer becomes 30 into 31 into 2 raised to 28. So it is 15 into 31 into 2 raised to 29. Then this product 31 into 15 is equal to 5 and 1 5 31. 465 into 2 raised to 29. So your requirement is that 465. Yes. Now question number 25. That A is equal to 1, 2, 3. The number of relations on A containing 1, 2, 2, 3, which are reflexive and transitive but not symmetric. You can see for reflexiveness we need 1, 1, 2, 2 and 3, 3 should be inside them. Then only it is what? Reflexive. So your relation should contain these 3 elements 1, 1 and 2, 2 and 3, 3. Then that must contain these 2 elements. That is 1, 2 and 2, 3. So this should be transitive. How many such relations can be possible? So I draw a line and add this, this is transitive only if 1, 3 should be there. Then this it is actually our first relation R1. How many such functions are required? Which are, the number of relation. So, 1, 2, 2, 3 and 1, 3 is there. Because of there is no 3, 1 and 3, 2 and 2, 1, it is not transitive. So, no symmetric. This is transitiveness is okay as used there. 1, 2 and 2, 3 is there, then 1, 3 should be there. Now look this. I just add one more term as in the form. Here I add 2, 1 is there. Because of 2, 1 is added, this will provide a 1, 1 is there. So it is what? Transitive. Because there is an element 2, 3, don't mind that 2, 3 is a singleton set of 2, 3, that itself be what? Transitive. And along this 1, 3 is there. So when you add this expression here and you do not include that 1, 2. 1, 2 is also there, but not including that 2, 3. So I write down that set of R2. This is actually what? R1. This R1 is there. That's actually what? It is a reflexive and symmetric. No, not symmetric, but it is transitive. I wish to add this is R1 and R2 is there. Along with the 1, 1, 2, 2 and 3, 3 and this compulsory element 1 by 2 and 2, 3 is there, and this transitiveness will provide you 1 by 3. Now I wish to add this 2, 1 is there. I add 2, 1. Then this is okay, but not including 2, 3 and no 3, 1. That means what? This 1, 2 and 1, 3, this will be clubbed to the form to form transitiveness, and 1, 2 and 2, 1 will give you what? This 1, 1. So it is transitive. Because of there is no 3, 1 and there is no 3, 2, it is not symmetric. Now along with this R3, 1, 1, 2, 2 and 3, 3. And again 1, 2 should be there, 2, 3 should be there, along for 1, 3 is there. And instead of 2, 1, I replace 3, 2. So that 3, 2, that there is no 1, 2 term. So there is no 2 1. Reverse 2 1 is not there, it is not symmetric. And 3 2 sir, 3 2 and 2 3 will be 3 3, that's already there. This transitive. But there is no 2 3. Sorry, it is actually symmetric, but this term is there. But without this 2 1 is inserted, it is what? It is again not symmetric. But as per the condition, this R3 is also what? Feasible situation is there. So actually confused one, but you can see one more element is added to make them, that definitely becomes symmetric. So this are the condition for, there is 3 such relation can be made, because all of them are reflexive and that return set should be transitive, but because of the reversed one is not included them, it is not symmetric. So they want to find it is reflexive and transitive but not symmetric, and finally it will become what? 3 such elements. So that ends the entire questions now.
Brilliant Study Center, India's #1 coaching center for NEET and JEE.